So the last aspect of reaction intermediate is carbon-free radical. Carbon-free radical. What is carbon-free radicals? Free radicals, they are neutral atoms, which always form from the homolytic what? Fission. Let's move to this. Carbon-free radical, they are electrically neutral atom or group of atom. They are electrically neutral what? Atom or group of what? Atom possessing unpaired electron. Possessing unpaired what? Electron. So free radical, they are electrically neutral atom or group of atom possessing unpaired what? Unpaired electron, and they are highly, they are unstable or they are highly what? Reactive due to the presence of what? Unpaired electron. They are highly reactive. They are highly what? Reactive due to presence of unpaired electron. And we always use dots to denote them. Electrically neutral atom, a group of atoms possess unpaired electron, and they're highly what? Reactive due to the presence of what? Of unpaired electron. And their products, or they are formed by homolytic bond fission. So what kind of bond fission produce free radical? Is homolytic what? Bond fission. So look at the free radical. We have a carbon atom like this, bond with what? With it. Here. So, and this is the arrow of reactants. And here we have what? Carbon. So before it give us this, the bond here, in carbonium what? In a carbanion, the carbon is more electronegative than Z. The bond shift to the carbon. In the carbonium ion, Z is more electronegative than what? That carbon. The bond shift to what? Z. But this time around, the two of them are of the same electronegativity. So the bond electron will share by the what? By the two atoms. By sharing this, so one electron will come to this side, you will draw it half. One will go to this side, you will draw it half. If you look at the arrow there, I do it in this form. This one means what? One electron go. But if I draw it in this form, complete arrowhead means what? Two electron go. Transfer. So I've explained it several times. So as a result of that, now on this carbon, we have dots. Then on this what? Z, we have what? Dots. So the product form here The products here are called radical or free what? Free radicals form. That's what we call what? Free radical. Then the next thing is what? Let's treat formation of free radical. Formation of free radical. So the free radical, as you all know, they are products of homolytic fiction. So what is homolytic fiction? The bond electron will share by the two atoms. And the free radical, I said what? They are neutral atoms. They don't have positive or negative, they have dots. The atom, which is what possess unpaired electron, and the presence of the unpaired electron make them what? Active or reactive. And they are also what? A paramagnetic element because of the what? The presence of what? Of unpaired electron. So how can we get what? Free radical. Take for instance, if you have a carbon, a chlorine molecule together, the bond in these two chlorine here, the one electron moves to this side, the other one electron moves to this side. So as a result of that, they will lead to what? Giving us what? Cl plus another Cl. The Cl we have here is what? Dot, and here we have here is dot. So the product come is what? We call it what? Chlorine radicals. Abi? And in case of, we can also have hydrogen plus what? Hydrogen and another hydrogen molecule. If the two undergo homolytic fiction like this, the half bond will come to this side, the half bond will go to this side. At the end of the day, we are going to have what? H plus what? Plus H. So the H will have what? Dots on top. Here we also have dots on what? On top. That's how we what? And then what? All this reaction, the formation of what? Free radical is always initiated, I forget, by what? UV light. Ultraviolet what? Light. UV what? UV light is always serve as catalyst here. Ultraviolet what? Light is the one that commonly initiates what? Formation of free what? Of free radicals. Or if we have again of CH3, no, of C what? H3, and we have H here. So to give you this, and at the end of the day, we have, what do we have here? CH3 plus H. What leads to the CH3? The bond here. The half will come to this, and the other half will go to this. So this will become dot, this will become what? Dot. Have you now? Let me add one more to it. In case of we have a compound like this, CH3 and CH3, a T. This T can also what? Split into what? Into two. Like this. So if you want to split it into two, what we do? The same scenario will happen. This half will come to this side, another one will go to this side. Have you now? So you will now later lead to the one we called what? CH what? 3 plus another CH3. So the CH3 that we have here, call it what? Radicals. So that is how what? The radicals form. Carbon free radical form or free radicals. Yes, and the last thing of this free radical is what? Stability of what? Of free radicals. Stability of what? Of free radical. Stability of free radicals. What is free radicals? They are electrically neutral. They don't have positive charge, no negative charge. Their own is what is an atom, but we always use dots to denote them. They are highly reactive because of the presence of the what nucleus of electron and their paramagnetic elements or molecule, the free radicals, and they can be formed by initiation of the what of a molecule with what with light. Yes, let me forget to put what light. Light is always here. Light is always here to give you what radicals. Give you what radicals. What is the stability of radicals? The stability of radicals can be explained by what? By inductive what? Effects. The stability of radicals can be explained by what? Inductive effects only, not by resonance. Mhm. So, and this stability of resonance of the reductive effect, we can have it like this. If you have a carbon atom with three alkyl group, we have another carbon atom with two alkyl group, carbon atom with one alkyl group, and we have a carbon atom without alkyl group. So on this we have dots. This dot tell us that what? They are radicals. And let me show you their electron releasing. They release electron to the carbon. Mhm. So in terms of the what of the stability, the tertiary carbon, this man, it will be tertiary carbon free radical, secondary free radical, primary free radical. Here we have methyl free radical. In terms of their stability, this man is more stable than this, This is the least stable. This is what? The decrease in what? In stability. In stability. Good. So that is all about what? The stability of what? Of carbon what? Carbon ion. So the next thing that I'm going to treat is what? Types of reaction mechanism.